Laws of logarithms, example 2. Simplify by writing as a single logarithm or as a rational number. So part A, 2 times logarithm of 7 minus 3 times logarithm of 2. Now let me use the laws of logarithms to transform this to the final form. So first, this 2 times logarithm of 7, it can be understood as logarithm of 7 squared. The reason for that is the law that the logarithm of x to the power of y is y times logarithm of x. And this is what we used here. So, but the only difference is that we started with the right hand side, y times logarithm of x, so y was 2, x is 7, and then we have the final left hand side here. So it's the logarithm of 7 to the second power. Now minus, and again we have 3 times logarithm of 2, so it must be a logarithm of 2 to the third power. Again, the same law was used. 3 is y, x is 2, and hence we have 2 to the power of 3, like this. Another law that I can use now, since this is the subtraction, I can use the law that says that the logarithm of the quotient is the difference in logarithms, so it can be written as the logarithm of 7 squared divided by 2 to the power of 3. And, well, let me write this law below. So what I used is the logarithm of x minus logarithm of y is logarithm of x over y. This is used here, and what I get is logarithm of 7 times 7 is 49 divided by or over 2 to the power of 3 is 8, and this should be the correct answer to this first part. Now in part B we have 2 times logarithm of 3 plus 3. So again this is an independent term, and then we add 3 to it. So let me use this power law here, this logarithmic law here, to transform this first term. So it's nothing else than logarithm of 3 to the power of 2 plus, and there is this 3 here. You may well remember the law that I mentioned in the previous video, and it said that the logarithm in base a of a to the power of whatever, let's say n, is, according to this third law of logarithms, it's n times logarithm in the base a of a, which is just 1, because it's 1 the power that you have to raise a in order to get a. So it's just n. This being number 1, this is n. So if I take 3 as n and I take 10 as the base, which is used here because there is the a is not written, but it's 10, it's supposed to be 10, I can say that according to this I can use it like this: a logarithm of 10 to the power of 3 is 3 times logarithm of 10. But what is the logarithm of 10 in base 10? It's 1, so it's 3. So I can use this and replace number 3 by logarithm of 10 to the power of 3. So now we have the sum of two logarithms, and it's a perfect occasion for us to use the the logarithmic law, saying that the logarithm of x plus the logarithm of y should be equal to logarithm of x times y, like that. So let me apply this. its logarithm of this number here is 3 to the power of 2, it's 9, so it's I have the improper color here, so let me use black one. So it's logarithm of 3 to the power of 2 times 10 to the power of 3. Okay, so it's 9 times 1000, so it must be the logarithm of 9000, and this should be the correct answer to this second part. Okay, now the third part, part C. We have logarithm of 8 divided by a logarithm of 4. Logarithm of 8 divided by a logarithm of 4. Now, you may notice that both 8 and 4 are powers of 2. So let me use this fact. I can replace 8, so it's the logarithm, and now replace 8 by 2 to the power of 3 divided by, and let me replace 4 by 2 to the power of 2, so it's the logarithm of 2 to the power of 2. Now, since we have the logarithm of the power, we can use this formula here, and we can rewrite the numerator in the form 3 times logarithm of 2, and the denominator in the form 2 times logarithm of 2. Since these two numbers, logarithm of 2 and logarithm of 2, are the same, we can cancel them out, and the answer to this part is just 3 over 2. And that's it. That's the answer